So we're asked to find the points of inflection for the following function. So let me go ahead and write out our function here. F of x is equal to x squared plus 1 over x. So our points of inflection, f prime, occur when 2x plus, now when I take the derivative of this, I'm going to get negative 1 over x squared, like that. So that is 2x minus 1 over x squared. Now let's just take a look at this. When we set this guy equal to 0, this implies that 2x would have to be equal to 1 over x squared. And that makes sense. If you want this thing to be 0, these two guys have to be equal to one another. Okay. So where does that occur? Well, let's go ahead and plug in these to solve this guy right here. So that means that 2x to the third would have to be equal to 1, or x to the third would have to be equal to 1/2, which implies that x would have to be the third root of 1/2. So we need the third root of 1/2. Okay, so let's just go ahead and check that guy. So the third root of 1/2 is 0.79. So what this tells us is that the only place where we can have, the only spot that we have a critical point at is 1/2. Excuse me, is the third root of 1/2. So that's over here at like 0.7. So the third root of 1/2. Okay, and we take this and we plug it back in here. It comes out to be some positive number. I'm just going to mark it up here somewhere. Okay, so it's got some height there. Now, let's take a look at f double prime. So f double prime of x is equal to the derivative of this guy, which is going to be 2 plus, now let's just go ahead and work with this. This is really 2x minus x to the negative 2. So the negative 2 comes out front, so I got the 2. The negative 2 comes out front to make it positive. I get a 2 there, and then I get x to the negative 3. So this is going to be 2 plus 2 over x to the third. Now, when that's 0, okay, when this guy is 0, we've got a possibility for an inflection point. Okay, so let's go ahead and check. The only time that this guy is 0 is, the only way to make this guy 0 is to let x equal negative 1. Now you can go ahead and test that out. This has to be 2 is equal to negative 2 over x to the third. And the only way to solve this, that's 2x to the third equals negative 2. So x to the third would have to be equal to negative 1. And the only solution for this is negative 1. So f double prime at negative 1 is 0. So over here at negative 1, we have a possibility for an inflection point. Okay. Now when I take negative 1 and I plug it into here, I get 1 plus negative 1, which ends up being a value of 0. So that point is on the curve. This point, this guy right here is a point, a possible, it doesn't guarantee that it's a point of inflection, but a possible point of inflection. This guy is, again, a critical point. Now, we don't know whether it's a min or a max, so I'm going to go ahead and I'm going to look at that here. So to determine whether this is a minimum or a maximum, I'm going to take this guy and I'm going to plug it in to the second derivative and see what I get. And when I take a positive number, like the third root of 1/2, and I plug it into here, it comes out to be positive. So since when we plug this in here, we get a positive value out, that means the second derivative here is positive, which means we must be going something like this. Okay. Now we know the function's not defined when x is 0. So we either have a whole or a vertical asymptote, and we're going to have a vertical asymptote here. Okay, and so now the question is, are we coming up like this, or are we coming down like that? But that's easy to tell. At -1, the second derivative at -1, okay, well, actually, let me go just a little bit to one of the sides here. If we put -1, let's just put it into the first derivative. This guy right here, that gives me a -2 minus a positive 1, which is still a negative value. So that means our function is decreasing on this at this point right here. So it must look something like that. Now, if we take a look at f triple prime of x, we get -6 over x to the fourth, like that. Okay, and this at -1 is negative, which is not 0. And since that's the case, since this is not 0, then this is a point of inflection. Okay, just like that.